Moving on to the third equation, which is n equals lowercase m over capital M. This is found in structure 1.4.3 and is used to convert mass of a substance into moles of a substance. Let's go through each variable. Lowercase n represents the number of moles of the substance with the unit mole. Lowercase m represents the mass of the substance in grams. And capital M represents the molar mass of the substance measured in grams per mole. The key to this equation is the molar mass because it is the component that relates the grams of a substance to the moles of a substance, which we can use as a conversion factor. Let's look at a sample problem and how you can calculate it using two different methods. Sample question. You have 45 grams of glucose, C6H12O6. How many moles of glucose do you have? Using our equation, we are given grams of glucose, which is 45. And we are looking to calculate the moles, which is the lowercase n. So in order to use this equation, we need to figure out the molar mass. We can find the molar mass of glucose by adding up the molar mass of each individual element, accounting for how many atoms of each element we have within the molecule. This information is found on the periodic table. So for glucose, we would take the molar mass of carbon and multiply it by 6, and the molar mass of hydrogen and multiply it by 12, and the molar mass of oxygen and multiply it by 6. Adding all of those up together, this gives us an overall molar mass of the molecule of around 180.16 grams per mole. We plug that into our equation, in which we divide 45 grams by 180.6 grams per mole, and that leaves us with around 0.25 moles of glucose. You can break this equation down in another way, which gets you the same answer, but is laid out differently, making it easier to see how units are canceled. You may have learned to write it this way in your chemistry class. In either case, whether you are using the actual equation or using the broken up conversion factor, you will get the same answer.